Okay, we're gonna do a reaction video.
Let's go through how to convert a number into a different base. Okay. For example, 11 in regular old base 10 is equal to 102 in base 3. Why is it equal to 102? Well, because we can write 11 like this. We can write 11 as the sum of a bunch of terms.
Yeah, here I should have said you can write 11 as the sum of a bunch of powers of 3. Something like that.
Where every term has two numbers in it. It's got a power of 3, and it's also got a constant term that, in the case of base 3, is going to be either 0, 1, or 2.
Yeah, just saying it like you can write this as a sum of a bunch of powers of 3, and each of the powers of 3 is multiplied by a number between 0 and 2, like up to 3, like 0, 1, 2. If it was base 10, then it would be like 0 through 9. I don't know.
So how do we actually write a computer program to do this? Well, I Googled this, and I came to a Stack Overflow post, which had an algorithm that looked kind of like this. I didn't understand it at first, so my goal with this video is to go through and understand why this algorithm here works.
That's good. That's pretty good motivation, I think.
So why does that algorithm work? Well, first of all, we just have to realize that any number that we have, we can write it as a sum of a bunch of terms where
I think this is kind of galaxy brained. Like, this is like a really compact way to write this, but it's like you just look at this and you're just like, what the heck even is this? It's like this C thing, this K thing. It's just like, it's not a good way just to like explain it.
every term is two numbers being multiplied, where one number is an exponential to a number.
Yeah, I should just say like where every every term in the sum has your base k raised to some power, and then the c thing is some number less than k, up to zero up to k minus 1.
And the other one is a term. Just like in the last page we saw. For example, 11, we can write it in this way. In this case, we have, we're writing n in base k, so k is 3. So we replace everywhere we saw a k with the 3 here. And we count up successive powers of 3 until we are able to represent the number that we started with. So why is it important that we can write every number in that way? Well, once we've written our number in that way, all we have to do is just read off the coefficients, and that's our number in our new base. So if we can get our number into this form, then it's as easy as just reading off the coefficients to convert the number. So how do we actually read off the coefficients of this number? And it might seem like I'm jumping ahead, because how do we actually get this number? Well, we don't have to explicitly actually convert our original number to this different representation of it. We just know that our number can be written like this, and because we know that that's the case, we can kind of pretend like we've rewritten it like this, and we just perform operations on it to read off these coefficients.
Yeah, I'm kind of getting at it here, but I feel like this thing is, it's like really, it's a really magical, mysterious thing that's going on here. It's like it's like you just have this number in hand. It's just like 11. It's just your normal number 11. Um, but like the number like exists in like all these other forms, I guess. It like exists in this form here. It exists as a sum of a bunch of uh, terms of powers of 3 multiplied by these coefficient terms. And it's like that representation just exists, and it's equal to this original number. It's just in a different form. So like you can just, I don't know, it's like you can like just start operating on it as if it was in this form. Even if you don't know exactly what the form looks like, you actually do know that it is like one form is a bunch of like a sum of a bunch of powers of 3 times these coefficients. And you just do this procedure to like read off these coefficients. Like you don't know what they are, but like a lot of them could be 0, and like you'll find that out by this process. But yeah, I just feel like in the original video I didn't really draw enough emphasis to like the magical, mysterious part of this. It really does feel that way.
So how do we do that? Well, one algorithm that you could come up with, there are many different ways to do that, but reading off the coefficients, we could do it like this. We could read off the rightmost coefficient and then say.
So the rest of this video is kind of like the like explores the kind of the part in the original algorithm, which is like the modulus part and the division part. It's actually like, yeah, doing that part. But I guess, yeah, with making this video, I just really wanted to draw attention to this like this like first step here with writing the number in this form, because I think the rest of the video is fine with going through the modulus and the modulus and the division and kind of like reading off, yeah, kind of like, I don't know, working with the number once it's already in this form. But anyway, I just wanted to talk about that first special part. Thanks.